All right, welcome. Today, we're going to dive into a system that, believe it or not, secretly runs the world all around you, the coordinate plane. And I promise by the end of this, you'll see it's not just some lines on a graph in math class. It's a really powerful universal address system for pinpointing pretty much anything, anywhere. So let me just kick things off with a question for you. What is the one thing that connects the world you're exploring in a video game, the GPS that's guiding your car, and the blueprints for a giant skyscraper? They all rely on the exact same fundamental idea, a perfect system for giving a precise address to any location. And that system is the Cartesian coordinate plane. The best way to think about it is like this. It's a way to lay a perfect invisible grid over any flat surface you can imagine. And this grid gives every single point its own unique address, which makes it totally impossible to get lost. So how do we actually build this master grid? It's way simpler than it sounds. It all just starts with two lines that cross each other. Let's build it from the ground up, right now. First up, we've got the x-axis. This is our horizontal number line. It goes left and right. Just picture it as the main street in our grid city. If you move to the right from the center, you're heading toward the positive numbers. Head left, and you're in negative territory. Simple as that. Next, we have the y-axis. This is our vertical number line, running straight up and down. So, if the x-axis is our street, you can think of the y-axis as the elevator in our building. Going up takes you to the positive numbers, and going down drops you into the negatives. And what about where our street and our elevator cross paths? That is the most important intersection in the whole city. We call it the origin. Its address is always 00, and it's the official starting point for finding any other address on the grid. Every single journey begins right here. Okay, so check this out. These two simple lines do something really cool. They slice our entire flat world into four distinct sections, or neighborhoods, if you will. We call them quadrants, and each one has its own unique vibe. We number them with Roman numerals, I, 2, 3, and 4, and we do it in a counterclockwise direction, starting from the top right. This little table shows the logic perfectly. In quadrant I, everything's positive, both x and y. In quadrant 2, you've gone left, so x is negative, but you're still up high, so y is positive. Down in quadrant 3, they're both negative. And over in quadrant 4, x is positive again, but now y is negative. These signs are like little clues that tell you exactly which neighborhood you're in. So we have our grid, we have our neighborhoods. How do we actually find an address, or as we call it in math, a point? Well, we use a super simple, memorable trick I like to call walk, then ride. I promise, it never fails. Okay, here is the golden rule, broken down. Step 1, you always, and I mean always, start at the origin, at 00. Step 2, the first number in your address tells you how far to walk along the x-axis street. To the right for positive, to the left for negative. Step 3, the second number tells you where to ride the y-axis elevator, up for positive, down for negative. Let's try a few, it'll make perfect sense. Okay, let's find the address 4, 3. So we start at the origin. The first number is 4, so we walk 4 units to the right along our street. The second number is 3, so now we ride the elevator up 3 floors. And boom, we're there. That's the spot. How about this one, -2, 5? We follow the exact same rule. From 00, our walk number is -2, so we walk 2 units to the left. Our ride number is 5, so we hop on the elevator and go up 5 floors. There it is, right in quadrant 2. See? You're getting the hang of it. Let's try one with 2 negatives. -3, -4. Okay, from our starting point, we walk 3 units to the left for the -3, then we ride the elevator 4 floors down for the -4, and we've landed ourselves squarely in quadrant 3. All right, one last one to really lock it in. 5, -1. You know the drill by now. From the origin, walk 5 units to the right, and then ride the elevator down just 1 floor. And just like that, you've found a point in quadrant 4. Now, you might be wondering, what happens if one of the numbers in our address is a 0? Does the whole system just break? Not at all. In fact, it's even easier. 0 just means don't move in that direction. It's really simple. If your x-coordinate is 0, like in the point 05, it means you don't walk left or right at all. You just stand still and ride the elevator straight up 5 floors. You end up right on the y-axis itself.
And if your y-coordinate is 0, like in -30, you walk 3 to the left, and then you don't ride the elevator at all. You stay right there on the x-axis.
So why have we been messing around with this grid? Because this simple system of addresses, it turns out, is the hidden foundation for so much of our modern world. I'm talking from the tiniest little pixels to, well, entire planets. I mean, just think about it. Your phone's GPS uses latitude and longitude. That's just a massive coordinate plane wrapped around the Earth. Every single pixel on the screen you're looking at right now has an X and Y address telling it what to do. Architects use this grid to make sure every wall and window in a building is placed with perfect precision. And video games? A character's every move is just a constant stream of changing X and Y coordinates. It's everywhere.
So, if you take just one thing away from all this, let it be this simple rule. The crucial point is, first you walk the x-axis street, then you ride the y-axis elevator. X always comes first. If you can remember that, you can find any address in this two-dimensional world, no problem.
And that kind of leaves us with a final thought to chew on. You now have the power to describe the precise location of any point on a flat surface. But what about something that's not on a flat surface? What's the address for, say, a plane flying high in the sky? Well, for that, you'd need a third number, wouldn't you? A third axis, a z-axis. But hey, that is a story for another time.